Hey, Alex from GMAT Ninja here. Welcome to another video in our Data Insight series for the new GMAT Focus Edition. This one's going to be on two-part analysis, specifically quant-based questions in two-part analysis. So what do you need to know? Well, the first thing is, if you know all the quant content that's on the quantitative reasoning section, there's nothing new to learn for this section. Okay, so if that's the case, what is there to go over? What are we going to cover in this video if there's no new content to learn? Well, the questions are presented in a new way, and that creates some wrinkles. So one thing to keep in mind is, for some of these questions, what you're ending up doing is trying to find a relationship between the two columns. In other words, you can't solve for the first column, okay, pick a value, then solve for the second column, pick a value. What you're finding is, okay, I can't solve for them separately, but I do have maybe an expression that relates the two. And what you end up doing at that point is saying, okay, how can I pick values that fit that relationship? Maybe that involves some trial and error. So we'll cover a couple questions that involve that wrinkle and see how to negotiate the challenges there. Now, you also might run into questions where there's excess information. In other words, you're presented a whole bunch of stuff, but only some of it is actually relevant for the question. So at that point, the goal is, well, first of all, don't panic. Don't think I must be missing something if I'm not using all the information. That's just what might happen on some questions. And the other is, don't get led astray and try to start incorporating information that's irrelevant. You want to read carefully, make sure you're just using the stuff you need, ignoring the other stuff. Okay, so one warning before we go into this video. There's some content involving percents and rates and other topics, and I'm not going to go into depth on that. So if that content leaves you behind, feel free to check out our Quant series. We have videos dedicated to those topics where you can kind of dig in and get solid on the basics. And once you know that, then you can come back and check out this video. All right, so I'm going to give you 4 questions. We're going to be including all of these wrinkles up here and seeing how to negotiate them. I'll give you 2.25 minutes per question. If you need more time, feel free to pause the video. Otherwise, you can, if you finish early, you can skip right to the explanation. We'll go through it together. All right, great. Let's take a look at the first question. All right, let's take a look at this first question. Francois and Pierre each owe Claudine money. Today, Francois will make a payment equal to 50% of the amount he owes Claudine, and Pierre will make a payment equal to 10% of the amount he owes Claudine. Together, the two payments will be equal to 40% of the combined amount that Francois and Pierre owe Claudine. Okay, great. So there's my setup. Select for Francois and Pierre amounts that Francois and Pierre could owe Claudine that are jointly consistent with the given information. Okay, so I've got a word problem here. I'm sensing if I'm dealing with percents, algebra is going to be helpful. So a good place always to start with algebra is defining some variables. Now, notice I'm solving for the amount that Francois and Pierre owe Claudine respectively. So maybe I'll start by defining variables to reflect that. F is equal to the amount that Francois owes Claudine. And we have Pierre, so P is equal to the amount that Pierre owes Claudine. Okay, now I'm anchored with some variables. I've got F and P, I'm clear on what they mean, so now I can start doing some translations. Francois will make a payment equal to 50% of the amount he owes Claudine. Okay, so the payment that Francois is going to make is equal to 1/2 F. That's the Francois' payment. So the payment of Francois. Okay, what's next? Pierre will make a payment equal to 10% of the amount he owes Claudine. Okay, great. So Pierre is going to pay 10% of what he owes. He owes P, so he's going to pay 1/10 of P. Okay, so that's the payment that Pierre is going to make. All right, so I'm just kind of going through methodically translating this language into expressions and seeing where it leads. Okay, so I finished the first sentence. Second sentence, together the two payments will be equal to 40% of the combined amount that Francois and Pierre owe Claudine. Okay, so let me start with the two payments, together the two payments. Okay, so these two payments taken together, that means add. So I'm going to add 1/2 F and 1/10 P, and that's together how much they're going to be paying Claudine. So it says together the two payments will equal 40% of the combined amount that Francois and Pierre owe Claudine. What's the combined amount that Francois and Pierre owe Claudine? Well, Francois owes F, Pierre owes P. So the combined amount, I'll just make a note of that, F plus P is the combined amount. And notice that the amounts that they're paying, the problem tells us, are equal to 40% of the combined amount. Okay, so 40%, well, 40% is equal to 2/5. So I'll say that sum is equal to 2/5 of the combined amount, F plus P. Okay, so where do I go from here? Well, one thing that concerns me is I have two variables in this equation. So I don't think, unless something happens that surprises me, I don't think I'm going to be able to solve for F, solve for P. So I can't just pick a number out of the Francois column. So did I do something wrong? Well, I'm pretty sure I translated all the information correctly. There's no information hanging around that I didn't make use of. So keep in mind, this could be one of those questions where I can't actually solve for the columns separately, but I can solve for a relationship between the variables. And if I figure out the relationship, I can use that to pick two answers that fit that relationship. Okay, so let's press ahead with the algebra, see if I can arrive at a clear relationship. Okay, so I'm going to simplify. I distribute the 2/5, so I get 2/5 F plus 2/5 P is equal to this over here. I want to get all the variables on the same side, or rather I want to isolate the variables. So maybe I'll do 1/2 F minus 2/5 F. So that's, 1/2 minus 2/5. Well, that's 5/10 minus 4/10. So I get 1/10 F on the left-hand side. And I'm going to do 2/5 P minus 1/10. Okay, 2/5, let me write that out, make sure I don't make a mistake. 2/5 minus 1/10. Okay, so that's 4/10 minus 1/10. So that's 3/10 P. Okay, 3/10 P. So, okay, I see there's a relationship between F and P. 1/10 of F is equal to 3/10 of P. Can I simplify that a little bit? Sure, might as well multiply both sides by 10. I get F equals 3P. Okay, there's a pretty clear relationship. I know that F has to be 3 times P. So F is going to be bigger. How much bigger? It's going to be 3 times bigger. So whatever P is, if I multiply it by 3, I should get F. Okay, so, well, if P is 50, 3 times 50 is 150. That's not there. Okay, so that first column is not going to be Pierre. Um, could Pierre be 250? Well, 3 times 250 is 750. Aha, that's there for Francois. Okay, so I want to fill in this column here, and I want to fill in this column here. Great, and that's the correct answer for this question. Okay, so what do we want to take away from that question? Well, notice I'm just using my tried and true percent skills, translating skills, defining variable skills, just like I do on the regular quant section. What's the difference? Well, this is a question where I can't actually solve for f or p, so I want to be aware, okay, that doesn't mean I'm necessarily doing something wrong. It could be just a question where I need to solve for a relationship. Once I know that relationship, I'm in good shape to pick a value from each column. Okay, great. Let's take a look at the next question. All right, let's take a look at this one. Supervisor's memo. At the present rate of manufacture, we will not have the 1200 circuit boards assembled in time to ship them to the customer. We currently have 10 workers, all working 8 hours a day at the same hourly rate, assembling the boards, and to date they've assembled 400. In order to finish the customer's order in time, I'll need to have each of the workers work an additional 2 hours for each of the 10 work days between now and the deadline. Okay, a lot of information there. Let's go on and see exactly what they're asking for. One can determine the hourly rate at which each worker assembled circuit boards up to the date of the supervisor's memo by dividing blank circuit boards by the product of blank worker hours per day and the number of days since the workers began assembling the circuit boards. Okay, so I need to find those two quantities. Now, I have a feeling that this equation work equals rate times time could be helpful here. I'm hearing a lot about work and rates and times. Let's see if I can wrap my mind around exactly what they're asking for. So it says one can determine the hourly rate at which each worker assembled circuit boards. Okay, so let me just stop there and process that. So I'm determining a rate, so I'll give a variable for this. Maybe I'll call this R1. And what is this the rate of? Well, it's the hourly rate for each worker to assemble the circuit boards. Okay, well if it's for each worker, then I could say, well, this is the rate per worker, and they're making circuit boards. Okay, now if I keep reading, it says this is the rate up to the date of the supervisor's memo. Okay, so maybe that'll be important later on. I want to make a note of that this is specifically the rate up to the date of the supervisor's memo. Okay, so how am I supposed to be able to find this rate? Well, they say, I should be able to find it. It should be equal to, or I should be able to determine it by dividing blank circuit boards. Okay, so I need to find that blank. Let me call it x. What is x? X is the number of circuit boards. But specifically, up to the date of the supervisor's memo, right? That's the time period we're interested in. Okay, so I'm dividing x circuit boards by the product. Okay, let me pause right there. I'm dividing it by a product. Maybe that's important. So notice, sure, this is a quant question, but it has a big reading comp component too. It's all about parsing the information, making sure I know exactly what they're asking for. Okay, so I'm dividing this by the product of blank worker hours per day. Okay, that's another blank. I'll give it a variable. Let's call it y. And it's, what are the units for that? They're worker hours per day. So the product of that and the number of days since the workers began assembling the circuit boards. Okay, so this is days. Okay, so I think I have my mind wrapped around what I want. It's X circuit boards that were made up to the date of the supervisor's memo and Y worker hours per day. Okay, let me just make sure that these units all make sense and my logic is correct. So if I multiply on the bottom, I guess days cancels with days. Okay, then I have circuit boards per worker hour. Okay, is that going to give me the hourly rate per worker? Well, sure, that makes sense. It's circuit boards per hour per worker, because I also have worker on the bottom there. Okay, great. So now I've got to hunt down circuit boards and worker hours. So if you're totally comfortable with the concept of worker hours, that's great. You should be in good shape. I'm going to do a quick aside for those who might find worker hours somewhat confusing. If you're totally cool with it, feel free to skip ahead to when I get back to the question itself. But worker hours, what the heck are worker hours? Well, it's actually just number of workers times the number of hours that they're working, or the time that they're working. Okay, it could be in minutes, could be seconds. I could have worker seconds, worker minutes. In this case, it's worker hours. So number of workers times time, and then that will give me worker hours. Okay, well, what are worker hours useful for? Well, let's say I had 5 workers, and each of them, so that's 5 workers, and I had 10 hours to get some work done. So the time equals 10. Well, you might say, in a sense, the amount of time is 10 hours, but if you have 5 people working, and they're each doing 10 hours, in a sense, that's like 50 hours worth of work getting done. So, 5 workers times 10 hours gives me 50 worker hours. And why is that useful? Well, if I know the rate per worker, so that would be, I don't know, let's say I'm getting some job done and I can make, 20 widgets. Each worker can make 20 widgets per hour. So I would say the workers make 20 widgets per hour. And again, that's for each worker, so it's per hour per worker. So worker also goes in the bottom there. Notice if I multiply that rate per worker times the number of worker hours, that gives me time and workers cancel, and that gives me 1,000 widgets that I can make. Okay, so again, just to summarize, worker hours, worker minutes, worker seconds, that's just number of workers times time. Why is that useful? Well, if you multiply worker hours times the hourly rate of each worker, it gives you the total amount of work. Okay, and that's what's going on here. Okay, so end of digression. Let's go back to the question itself. Okay, so I'm trying to hunt down the number of circuit boards that were made up to the date of the supervisor's memo, and I'm trying to find y, the number of worker hours up to the date of the supervisor's memo. Okay, so first sentence, at the present rate of manufacture, we will not have the 1,200 circuit boards assembled in time to ship. Okay, that's the number of circuit boards they wanted to make, but they didn't make them, so that's not relevant. We currently have 10 workers, all working 8 hours a day. Okay, well, that's going to be helpful for worker hours. Number of workers equals 10, and so the time for each of them is 8 hours. Now, sure, it's 8 hours per day, but notice in the expression they gave me, they say I'm going to be multiplying it by days. So hours per day times number of days will give you the total amount of time. Okay, cool. So I think I'm happy with these quantities here. If I multiply 8 by 10 workers times 8 hours per day, that gives me 80 worker hours per day. That's exactly what I was looking for. Okay, cool. So I guess I accidentally solved for blank 2 first, but nothing wrong with that. Number of worker hours is 80. Pardon me, worker hours per day. Okay, now I just need to find the number of circuit boards that were made up to the date of the supervisor's memo. I keep reading. To date, they've assembled 400. Boom, there we go. They've assembled 400 circuit boards, and I've got my answer to this question. 80 worker hours per day, 400 circuit boards, and we're done. Okay, cool. So what are the take-homes for this question? Well, notice I was given a lot of information, and in fact, I didn't need to use it all. I just needed to use a portion of it. So as you're going through a question, the first thing to keep in mind is don't panic just because you're not using all the information. Doesn't mean you're doing something wrong on these two-part analysis questions. It could just be a question that's structured like this. They throw a bunch of extra stuff at you, and your goal is just to figure out what's essential, what's not essential. The other thing is don't get thrown off and try to start incorporating all the information. Don't let the extra stuff that they're telling you muddy the waters, right? If I started messing around with that last sentence, okay, in order to finish the customer's order in time, I'll need each of the workers to work additional 2 hours and all that information, that could start confusing me. Notice I realize when I'm carefully analyzing what they want, I realize that's irrelevant and it doesn't get in the way. Okay, great. So that wraps up this question. Let's take a look at the next one. All right, let's take a look at this question. Edgar was among those responsible for purchasing door prizes for his company's party. Edgar purchased 6 items for 10x dollars each, Y items for $30 each, and no other items. The total amount of Edgar's door prize purchases was $600. In the table, select the value of X and the value of Y that are jointly consistent with the given information. Make only 2 selections, one in each column. Okay, so the total amounts that Edgar spent was $600. Okay, I'm going to translate the information I'm given. Edgar purchased 6 items. Okay, so there were 6 items of one type. Those cost 10x dollars each, so it's 10x dollars per item. He went on to buy Y items. These are different items. These cost $30 per item. Okay, no other items. So if I add up the amount spent on the first type to the second type of items, then I'm going to get a total of $600. Okay, so how much was spent on those first 6 items? Well, it's 10x dollars per item, and there were 6 items. So if I multiply those together, I should get dollars. So I'm going to say 60x dollars on those first 6 items, following the same logic, 30y dollars for the next y items, and that's a total of $600. Okay, so I translated all the information. I get to this equation. Now I notice I can't solve for x. Can't get a number for x by looking at this. Same thing for y. I can't get a number for y. Does that mean I did something wrong? Not necessarily. You'll run into some questions where you can just solve for the number in one column, pick that, do some more work, solve for the number in the second column. But just because that's not the case doesn't mean you did something wrong. Like on the first question we saw, you can just solve for a relationship between the variables. Okay, on that question, it was a ratio between the variables we solved for. It was pretty easy to eyeball, well, which of those two numbers in the columns are going to fit that relationship. Here, it doesn't look like a simple ratio. Okay, but I'm going to try to simplify this as much as I can to make this process of picking values for x and y easier. Okay, these are kind of big numbers, so let's see, is there any way I can shrink them? Well, I notice they're all divisible by 10. Anything bigger go into all these? Well, I notice 30 goes into all of them. Okay, great. So I'm going to divide everything by 30. I get 2x plus y equals 20. Okay, this is much more manageable now. If I'm going to think about what values of x and y work, well, I can't just eyeball it immediately, see the relationship between x and y. So I'm going to have to do some trial and error. Okay, but I'd much rather do trial and error with these smaller numbers than with these big, ugly numbers. Okay, so now how am I going to do this trial and error? Should I just do it blindly, just pick every value of x and see what the value of y would be and get to it that way? I guess that wouldn't be terrible here. These numbers are small enough. I don't think that would kill my time. On the other hand, it's always good to look for the most efficient path you can get. If you can save yourself some time, that's great. Do less calculations, less likely to make a careless error. That's all good stuff. So let me think about the number properties I know and multiples and digits, and does that help me narrow down some possible values so I can do intelligent trial and error rather than just blind? Okay, well, I notice 20 is an even number. Okay. Uh, 2 times any number is going to be even, because an even number times any number will give me an even number. Okay, so 2x, that quantity has got to be even. So what does that tell me about y? Well, y has to be even, because if y were odd, then an even plus an odd would give me an odd, and I know that's not the case. So, okay, cool. Y has to be even. So that really narrows down the possibilities, right? Y could not be 3, 5, 7, or 9. It's got to be either 4 or 8. Okay, I can live with plugging in just 2 possible values of y to see which of those works. Okay, could y be 8? Well, if y is 8, then I have 2x equals 12. X would be 6. Okay, there is no option for 6, so that's not going to work. It's got to be y is 4, but let me just make sure. So if y is 4, I subtract that from the other side, I get 2x equals 16, and x equals 8. Okay, great. So 4 works for y, 8 works for x, and that's the right answer for this one. Okay, so what do you want to take away from this? Well, I'd say just because you can't solve for one variable doesn't mean you did something wrong. That's just something you want to remind yourself on these two-part analysis questions. However, you are going to be able to, at some point, to solve for a relationship between the variables, and you'll be able to find, what's the values that fit that relationship. So at that point, you're kind of dealing with trial and error. So it's always good when you're doing that trial and error process to say, is there some intelligent way I can do this instead of just blindly cycling through the numbers? Is there a way I can think about the information that I'm given that narrows down the options that I can pick or somehow makes that process easier? In this case, thinking about evens and odds really reduced the possibilities for y, made that a pretty efficient process. All right, great. Let's take a look at the next question. All right, let's take a look at this one. The finesse of a gold bar is the weight of the gold present in the bar divided by the total weight of the bar. A jeweler has 3 gold bars. The 3 bars have identical weights, and the first 2 bars have identical finesse. If all 3 bars were melted and combined into one bar, the finesse of the resulting bar would be 0.96. Okay. Select a finesse of the first 2 bars and a finesse of the third bar that are jointly consistent with the given information. Okay, so they're asking for the finesse of the first 2 bars. Maybe I'll give myself a variable for that, f1. That's the finesse of the first 2 bars. And they're asking for the finesse of the third bar. So I'll say maybe f3, and that's the finesse of the third bar. Okay, so they also give me the definition of finesse. They say, F is equal to the weight of gold. Maybe I'll say G over W. Okay, so probably makes sense to write equations for the finesse in terms of the gold and the weight for these two. So I'll need to define some variables. I'll say, G1 is the weight of the gold for the first 2 bars. And I'll say the same thing for the third bar. G3 is the weight of the gold for the third bar. Okay, and the weight they say is the same for all 3, so I've just got W is the weight of any of the bars. All right, so can I get an expression for the finesse of the first bar? Sure, that would be G1 over W. Finesse of the third bar would be G3 over W. Okay, so far I haven't incorporated that number that they gave me, the only number in the problem actually, 0.96. What is that? Well, they say that's the total finesse. The total finesse is 0.96. Maybe I'll define total finesse in terms of gold as well, like I did these. So it would be, if it's the total finesse, I guess it's the total gold over the total weight. So I'll say the weight total. Okay, so if I'm melting down 2 of these bars, I'm melting down all 3 and combining them, how much am I going to get from the first 2 bars? Well, each of the first 2 bars has G1. That's their weight of gold. So I guess they're contributing to G1. What about the third bar? Well, I just have one of those. That's contributing G3. Okay, so that's the total gold. If I divide that by the total weight, well, I've got 3 bars that were melted down. Each one has a weight of W. So when I combine them again, I guess they'll each still have a weight of W. So the final weight will be 3W of that final bar I've made. Okay, great. So there's an expression for the finesse of the combined gold bars, and it's equal to 0.96. Okay, so that's all well and good. The only issue is they're asking about finesse, and somehow those are missing from my equation. So can I somehow use this to work my way back to F1 and F3, which is, after all, what I'm looking for? Well, notice, yes, G1 over W, that's what I have in this equation, that's equal to F1. And what do I have here? G1 over W. And same thing for F3, that's G3 over W. Okay, so I'll split up the denominator to make 2 different fractions just to do this really explicitly, right? If I have 2 things being added divided by something, I can always split up the denominator. And then I see, okay, G1 over W, that's just F1. So I'll get rid of that. I'll say G1 over W is just F1. And G3 over W, that's just F3. Okay, cool. Now I have finesses in the picture again. That's good news. To make things simpler, since they're both over 3, I'll combine those 2 fractions. So I have 2F1 plus F3 over 3 equals 0.96. And that's an equation that relates to variables I want, so I think I'm in good shape. Okay, now I do notice, well, it would be nice always if I could solve for just the first column on its own, get a value for F1 and pick an answer. It doesn't look like that's possible here, right? I've kind of done as much algebra as I can, and I'm left just with this expression. And again, there are some questions where you'll be able to do that. You'll be able to solve for one of the variables, but it could also happen on these 2-part analysis questions that you won't. You don't want to panic. You just want to say, okay, that's all I can do here. I guess I just need to, figure out 2 values that will fit this relationship that I've figured out here. Okay, so how are we going to do that? So at this point, I think there's kind of a fork in the path. There's kind of 2 approaches we could take to try to figure out what values of F1 and F3 fit this. Okay, one of them is to simplify this expression and then just kind of look at it and see, can I logically figure out any limitation on the values of F1 and F3 so that I can do some intelligent trial and error, not just pick blindly, but pick ones that, some of them have to work, right? I can eliminate the ones I can throw out, and that leaves other ones as the only possibilities. So let's simplify this. I get 2.88 equals 2f1 plus f3. Okay, so that's a simpler equation to deal with. That's taking things in the right direction. Now, what do I notice about this sum? Well, it's going to give something that has a hundreds digit that is even. Okay, cool. So each of my other options, they end in hundreds digits, and that means this one, 2 times that, is going to have to also end with an even hundreds digit. So what does that tell me about the hundreds digit of f3? It can't be odd, right? An even plus an odd is going to give me an odd. So the hundreds digit of f3 has to be even. So f3 cannot be 0.93 or 0.99. Okay, cool. So that reduces the amount of work I'm going to have to do. I just have to test 3. All right, let's test 0.98. Okay, so if I subtract 0.98 from 2.88, notice at that point the hundreds digit is going to be 0. Right? And I might just scan these and see, is there anything here that if I multiply it by 2 would give a hundreds digit of 0? No, right? None of these ends in a 5. They're all going to give a hundreds digit that's not 0. So 2f1 can't give something with a hundreds digit of 0. f3 can't be 0.98. Okay, save myself a little bit of arithmetic there by kind of being alert to the digits. What about 0.94? Okay, so if I subtract something with a hundredths digit of 4, I'm going to end up with a 4 there, and I guess 0.92 is a candidate. So let's see, maybe this will work. So that's 4. This is 9. 1.94. Okay, so now the only possibility that would work for f1 at this point is 0.92. What's 0.92 times 2? It's 1.84. Okay, great. So 0.94 is not going to work for f3. So it's got to be 0.92. Okay, so at that point, I'm in good shape. Let's just confirm that that works, though. You want to make sure maybe I didn't make some silly mistake along the way. So 2.88 minus 0.92, that ends in a 6. And there are things here that when I multiply them by 2 will give a 6. Okay, so this could work. I get 1.96. If I divide that by 2, I get 0.98. Okay, cool. So again, I narrowed the possibilities for f3 down to the ones that end in an even digit. Eventually, I worked my way to 0.92. That seems to work for the third. And then if I solve for f1, I get 0.98. And that's the correct answer. Okay, so that's one path. Once I have this expression, I simplify it a bit, and then I use my odd-even logic and some digits logic to kind of make the process of trial and error a little less painful, a little bit less time-consuming. Okay, so there's another path. I think of this as very much kind of like a bonus. If it makes sense, if you can see it, great. If not, I wouldn't worry about it. It's not 100% essential. But I do notice, looking at this, that this is like a weighted average. Okay, I'm finding an average between the two finesses, and I'm getting an average finesse of 0.96, And maybe if I was really alert, once I was setting up the problem in the first place, I might have a sense of that's what's going on here. Yeah, I have finesses that I'm combining, but it's essentially a weighted average, and the result of the weighted average is 0.96. Okay, great. So this equation shows that. How do I now pick an f1 and f3 that fit that? Well, in a weighted average, I know that the result is going to be closer to the more heavily weighted of the two things that I'm adding up. So in this case, I've got 2 f1s and only 1 f3. So f1 is going to be closer to 0.96 than f3. So if I do like a number line representation, I could say, well, here's 0.96, and f1 is going to have to be closer than f3. Okay, now you might say, well, how did you know that f3 has to be smaller and that f1 has to be bigger? Well, yeah, that's true. I kind of don't. So f1 could be bigger or smaller, but either way, I know that f1 is closer to 0.96, f3 is farther away, and those are the two ways that could happen. Those are the two options. Now, because it's 2 times f1, I know that f1 is going to be twice as close, right? Or f3 is going to be twice as far away. So if this is x, if f1 is x away from 0.96, then f3 is 2x away. Okay, and I could write the same thing over here. Okay, now what can I draw from this? Well, similar to the last one, if these f3 is 2x away, then I know that distance is going to have to be an even number. So I'm going to be subtracting an even number from 0.96. So similar logic, I can realize f3 is going to have to be even. So that limits me. I can get rid of 0.93 and 0.99. So f3 has to be one of those even ones. So which one should I test first? Well, last time I just sort of blindly started testing them, thinking about some number properties which helped. But is there anything here that can point me in the right direction? Well, if I think about the fact that f3 is going to be farther away, I'm thinking, well, f3 is far away from 0.96, f1 is close to 0.96. So would I rather go down or go up? Well, I've got, more room to go away in the down direction, right? I could go all the way down to 0.92. If I'm going up, then I'm going to 0.98. That's the biggest value for f3 that's available here. And again, I know f3 is going to be far away, so I think that given the data, it's going to be more likely this. Or given the options, this is more likely. 0.92 is far away from 0.96, so that's the first one I'm going to test for f3. Again, if I do that, the arithmetic works out. I get f3 is 0.92, f1 is 0.98, and we're all set. Okay, great. So what are the takeaways for that question? Well, like a lot of the other ones we worked through, you don't end up being able to solve for one of the columns independently. You just end up with an expression or an equation rather, that relates them. And so then at that point, you're left with some trial and error you have to do. And the goal is, can I find some intelligent way to do it? There may be some cases where, well, maybe you have no option but to kind of power through, but it's always good to look and say, is there any options I can eliminate? Any ones that I think are more likely to be right, and I'll try those first, so that you can maximize your efficiency. All right, and again, that leads us to the correct answer of third finesse of 0.92, first two of 0.98. All right, and that concludes this question. All right, well, thanks so much for watching. I hope you enjoyed the video. And just to review some of the highlights, so no new quant content. If you know everything you need to know for the quantitative reasoning section, you don't need to learn new quant content for this. So what's the new stuff? Well, basically, be aware, don't freak out if you can't solve for the first column, can't solve for the second column, can't find those values separately. Some questions are going to be like that. So what do? Well, figure out a relationship between the columns and then see which of the numbers fit that relationship. Some trial and error might be involved, hopefully some intelligent trial and error. Okay, what else? Well, don't freak out if you realize that you're given a ton of information and you're not using all of it. That could just be the case. They're giving you some stuff that's relevant, some stuff that's irrelevant. Don't get misled by the irrelevant stuff. Focus on what you need by carefully reading. Doing all that stuff, you should be in good shape. All right. Well, thanks again for watching. I'll see you next time.